Here's problem 3614. The actual depth of a shallow pool, 1 meter deep, is not the same as the apparent depth seen when you look straight down at the pool from above. How deep will it appear in centimeters? Alright, so let's say we have a pool of water, and let's just put an object at the bottom of this pool. Let's put a fish at the bottom, and so the fish is what's going to be producing our light, and so that would be our object distance. In this case, 1 meter, or well, we'll just say 1 meter down below. So we have light coming from this fish, and as it encounters going from a higher index to a lower index, it will refract away from the normal as it goes into the air, and that would happen somewhat like this. So if we were to follow these light rays back from an observer point of view, the fish will appear to be closer to the surface than it actually is. So as an observer, that's how things look to us. As we're looking down at this fish, it appears like we might be able to just reach right in and grab this fish, even though it's deeper than what we really think. We can treat this like an interface problem as we're going from one index, in this case N1, to a second index of refraction, N2. And it's true for such refraction that N1 over our object distance plus N2 over our image distance is equal to N2 minus N1 over the radius of curvature of this interface. The radius of curvature is determined in terms of the location of the center of curvature on the outgoing side of the rays. In this case, though, we have a flat surface, so our radius of curvature is infinity, and hence the second term in this equation is going to be 0. So we'll have that N2 over Q is equal to a negative N1 over P, or solving for Q, Q will equal a negative N2 over N1 times P. So that is our image distance in general, and in this case that's going to be N1 being the water, 1.33, and N2 being the air. Our Q is going to equal a negative 1 over 1.33 times the depth, which is 1 meter. So this is going to be equal to a negative 3/4 or a negative 0.75 meters. Negative means that our image is not on the side of the outgoing rays, it's on the side of the incoming rays in this case, so it's actually below the water, not above the water where the outgoing rays are reaching our eyes. So the image is below the water at a depth of 0.75 meters. So in terms of centimeters, it will appear to be 75 centimeters below the level of the water, when it actually is 100 centimeters below the level of the water. So that's our answer. 75 meters is our depth.